So look at the next question. So we have to find a certain integer between 1 to 1200 which leaves the remainder 1 to 6 when divided by 9, 11, 13 respectively. What is that integer? That's the question. So we have to find, this means we have to find x, right? Which leaves the remainder 1 when it divided by 7. So it is what? X congruence to 1 mod 9 and x congruence to 2 mod 11, x congruence to 6 modulo 13. So this is the question. Again we have to compare this with the standard form of this linear congruences, and we have to get the values of a1 a2 a3 and m1 m2 m3, and as soon as we get the value of m1 m2 m3 we have to calculate m1 into m2 into m3, which is capital M. Okay, and after finding this value we have to calculate capital M1, capital M2 and capital M3 using this formula, right? And after getting this we have to calculate M1 inverse, M2 inverse and M3 inverse using these equations, and later let us substitute the value of M1 M2 M3 inverse, and look here. So we got this value now. Here 143 into m1 inverse congruence to 1 modulo 9. The thing is, you have to consider, let us substitute m1 inverse equal to 1. So 143 minus 1 divided by 9. No, it is not divided by 9, divisible by 9. So let us consider 143 into 2 minus 1. Is that divisible by 9? No. So 143 into 3 minus 1. Is that divisible by 9? No. So 143 into 4 minus 1. Is that divisible by 9? No. 143 into 5 minus 1. Is that divisible by 9? No. 143 into 6 minus 1. Is that divisible by 9? No. So 143 into 8 minus 1, is that divisible by 9? Yes, so it is divisible by 9. So m1 inverse is 8. So look at this equation. 117 m2 inverse congruence to 1 modulo 11. So let us substitute m2 inverse equal to 1. So 117 into 1 minus 1. Is that divisible by 11? No. So 117 into 2 minus 1, is that divisible by 11? No. So 117 into 3 minus 1, is that divisible by 11? No. So 117 into 5 minus 1, is that divisible by 11? No. 117 into 6 minus 1, is that divisible by 11? No. 117 into 7 minus 1, is that divisible by 11? No. 117 into 8 minus 1, is that divisible by 11? Yes. So here m2 inverse will be 8, right? In a similar manner we have to calculate m3 inverse, right? So m3 inverse is what? 99 into m3 inverse congruence to 1 modulo 13. So let us start with 1. So 99 into 1 minus 1, is that divisible by 13? No. 99 into 2 minus 1, is that divisible by 13? No. 99 into 3 minus 1, is that divisible by 13? No. 99 into 4 minus 1, is that divisible by 13? No. 99 into 5 minus 1, is that divisible by 13? Yes. So the answer is m3 inverse equal to 5. Okay, so after getting these values, so by Chinese Remainder Theorem it has a unique solution. So and we know the solution. Let us substitute these values for the equation, and we have this. So 5986. Let us divide this 5986 divide that by 1287. So we got 4 point something, right? So let us multiply 4 to 1287 and let us subtract this value from what? 5986. So 838 is the answer. So that is the required solution.